If
No, it's like
In theory, yes.
If everyone is going 70, you need to match them so you're not the danger.
I just taught you to say it.
But what they could do is they could.
Unless you're the last
We'll
person.
play it. Alright, so here we go. Okay, here we go.
Well, you're the only one driving different. You are the flow of traffic on that road. You're the only one there.
No.
That is so true though.
Hey, that's why there's the limit. So, alright, now, okay, in the math, what they have is black hole, scenarios. The idea is that when you divide by 0, you can't do that. So the idea is that anytime you're dividing by 0 or you're going towards infinity, that's when we're approaching a limit. We're finding a limit that will give us a correct answer that maybe isn't dividing by 0. Something, because on that third example, if you were to plug in 2, it would give you 0. 0 over 0. You can't do it. So we have to simplify that problem differently.
0 over 0.
Okay, and notice this, it has to be a reasonable estimate. So that's within reason, okay? So, let's go to the actual formal definition that we need to have here. Okay?
2 times 10.
So,
0 over 0.
if you're looking at this, how do we know that we're right on these problems? In theory, we don't know we're right on certain problems. Certain problems do have limits because you can see the graph, there's a lot of evidence you can point towards that point. But on certain problems, that's why, like in this class, we're going to learn the very basics of finding limits. And when the problem gets to a point where it's so difficult that all of the tests that I give you and all the predictions we use can't justify it, we honestly don't know an answer for it. We just make that guess and say it's got to be here. And in fact, it may not match the reality of that problem, but that's what all the math is pointing towards. And I'm going to show you that example later. That's going to be one of our last examples today. Okay? All right.
So,
Now, so, okay. Here's the next thing I want you to think about. Okay? The limit is basically a question that says, and I put in quotes because this is what those professors said. What if? Okay.
That's how are you going? Bye, Mr. Ward.
Okay, good luck.
Have a nice day, Mr. Ward.
Yeah. All right. So it's a hey.
I am getting up now.
Okay. It's a what if. Okay, that's what a limit is. It's what would happen in this situation. What if this were to take place? So as we're growing or we're getting 0 over 0, that type of thing. So the idea is that we don't need to make a prediction. You don't need to guess beforehand. There's rules that we're going to have in this class. We're going to learn that we can make what I call a consistent and improved estimate to the answer. So that's the idea. The closer we look. Now here's the more complicated stuff I need to explain. Okay. Oh, there's that prediction.
The limit does not exist.
Right here. Okay, these are the terms we're going to be using in this class. We're going to use deltas. That's a Greek term that we're going to use. It basically, or epsilon, or the idea is it's an error margin. So in math meanings, like for every real epsilon greater than 0, it's that there exists a real number delta greater than 0. Like this is a bunch of jargon math.
That's delta.
You're gonna see a lot of this terminology. What they're trying to explain is that there's an error margin on an answer. Like it's your speed limit. You can be above and you can be below the speed limit, right? As long as we're close, you're golden. You're good. Okay? You can be a couple miles over, a couple miles below. The idea is that what all of this jargon means, what they're saying here, is that we're going to try to actively and really closely predict what the answer of a problem will be by using those margins, by getting those margins smaller and smaller each side. So to get that flow of traffic, to get what the speed limit is, we want to be accurate. This is the type of math you're going to see in your book a lot when you look at examples. They're going to say, hey, I need to be less than some delta margin. I want to be less than 2 steps away from the middle. I want to be 2 miles an hour.
Can you draw a delta for me right now?
Isn't delta?
Rusty.
It looks like a note to me.
I thought delta
That's what I
was
use
the
as delta. I
triangle.
use it's a
That's not a note.
so yeah, it looks like a note to me. So I know you're thinking of the change, the delta triangle change. Yeah. I call it delta. It looks like a D. I don't actually know the correct term for it.
Oh.
So I just call it delta. That's what I've always called it.
Greek
Even that's what
alphabet.
my it is Greek term. I just don't know the actual
Yeah, let's
terminology
look it
for it. Yeah. So, but
It's different in
the idea is that I want to be within a margin of X. So I want this margin where my band of my speed limit is. I want to be in a certain range around it, and then that will actually give me an that'll actually give me a range around where my limit is. Like, as I go from the right and left side, getting closer and closer on my graph, can I actually predict where that thing is going to be? And I want to be as close as I can. So they call it delta. That's what they
You
say.
use two different characters.
Oh, that is delta.
It's just, that's what my professor always called it. I call it delta. What's the triangle?
It's a lowercase delta. The
Okay.
triangle is an uppercase.
Okay, there you go. So my professor said it right in college. All right, so then epsilon, this term is what we're going to be using when we're comparing the functions themselves. We'll go through more of this, but I want you to get used to the math jargon. And basically, we're trying to get as close as we can and predict the answers. Okay, so now let's get to our actual problems here today.
I feel like we're not.
Okay,
Mandarin oranges?
so let's go to this first one.
You want some?
Shh. Okay.
I don't like
I
that.
don't have it.
Hey, on the first problem we did today, okay, now that we kind of have this idea what we're doing, we're guesstimating answers, we're getting as close as we can. This is the start of something we should have learned last year, and we did. We call it the differential quotient. It's a part of limits. It's how we can evaluate things at certain numbers. For instance, this is my function up here. Okay, this is f of x. So when I plug in this formula, this is what you should be writing down. H should be on the bottom. You're gonna subtract the original f of x out the back, 3x plus 4.
So I got that.
And in the front, this right here, we're taking the original function, but you're putting an extra plus h into it. You're substituting in extra variables. So this is what we're going to have. We're going to plug in an extra x plus h anytime you see a variable on the problem. You're substituting it in, right? And then what we do is we simplify. What will happen if you simplify correctly, it'll give you the prediction what will happen. So the idea is that when I distribute, here's what we get. We get 3x plus 3h plus 4. And then I'm going to distribute the negative sign, so negative 3x minus 4. And this is all over h. Now, does anyone remember what I told you about doing these last year?
Everything but the
three.
H's should cancel.
Exactly. Everything but h's should go away. So if it doesn't have an h, it probably cancels, and you're actually seeing that it does. The 3x's go away, the 4's go away, and what we're left with is a 3h over h. And the h's will eventually drop out, and you're left with 3. What you're doing then, that is a form of a limit where it's actually predicting what slope is. It's called an average rate of change. It's a derivative. It's the concept of what we're learning in chapter 2, which is a limit. All right, questions at all about how to do that first one? That should be like a mini review. Now, let's get to the graph problem.
Certainly.
Okay, now we're starting to see the notation for a limit. This is what they say, the limit as x approaches 0. So as we get closer to the speed limit in the road, from the right and left side, what will happen on that function as we get closer to x being 0? As we get closer and closer to x being 0, what's the answer on your graph?
2.
2, that's the answer.
High road.
This is the answer, the theoretical answer, because as I get closer to 0, this is what the graph is doing.
Why couldn't you just tell us that?
Okay, can't say because I want to see if you guys knew it beforehand.
We did
Hey, I got that
not.
right.
Okay, so this is 2. It's 2 on the y-axis.
I really need to use it.
Okay, now, going back to that crazy complication earlier, it said in that little slide that I gave you that in theory, your limits won't match reality sometimes. That, the graphs could be going different places, but the answer for the graph could be something else. Your limit answer can be different than the functional answer.
Could it be like 72?
This answer could be 72 there.
If it went
For
for
the
like
function.
36s.
So, because
Just because it spikes up real high.
well, it could be a spike, or there could be holes in the graph. But the limit is saying that it's approaching this number, but everything is going higher. So going back to the speed limit, right? Let's say you had your 50 friends traveling 90 miles an hour down 18. I'm going to use that on camera. I don't want to.
50 friends on 18?
So here's the idea. So
If you don't have 50 friends,
Okay, well that's not a problem for you, Sydney.
okay, so you got your 50 friends.
Oh.
Okay, you got your 50 friends that are going.
I was gonna say that's only a problem for you,
So-
but I thought that was too
Have you ever
hard.
been in a car going more than 400 miles per hour?
What?
Have you ever been in a car going more than
Yeah, he's
400
lived a little.
So
You don't
Okay.
lie.
now,
Now.
Alright, stop asking. Alright, now,
He said,
Okay,
as long
let's
as
say you
you're
had
the
your-
leader
hey,
of the group, it's
let's say you had your 50 friends going 110 miles an hour down 18, but then the flow of traffic, everyone else going down 18 is going
55.
55, but your select group. Okay? Everyone else going 55. The limit, the speed limit of 18 is 55.
Right.
The problem is the functional value, though, the function of Highway 18, what you guys, like when you guys were going down the highway, you were getting 110 miles an hour. The problem is the limit, as I approach the left and right, and other than your select group of people, should have been 55.
We're gonna convince everyone.
Okay, no. So, so the idea is that your functional value at Highway 18 is 110, but the limit isn't. The limit's 18, because you're seeing everyone else is going 55 except for you.
You just said the one.
The reality doesn't have to match what the limit says. Okay? It's just, because, in certain big cities, like Des Moines, they go way faster than the theoretical, 50, 60 miles an hour that they have on Highway 84.
Yeah, you'll be going
Minnesota.
going on the interstate, they cut it down to like 60, and people are zipping.
They're
by.
zipping
You're
by,
like
they're going
70,
70 or
yeah.
75, because they're doing the flow of traffic, as long as everyone's going that speed, no one's getting pulled over.
What is the limit for the Autobahn?
Autobahn is, there's unrestricted zones, so I think they just say within reason,
But-
if there's traffic, you're supposed to slow down. But it's like 120
But
kilometers
have you
per
heard
hour,
what they
so,
do? They pull you
some
over
people-
for emissions if you're
Yeah.
going over 175
Yeah.
kilometers an hour,
okay,
which is like.
now, hey, let's get to your last problem today.
Wait, I have a
200
question. Do you
kilometers an
think
hour,
we
they
should
pull
change
you over
the
for
speed
emissions,
limit
'cause you're
from
not being very
55 to
efficient as you're,
65?
Yeah, in Jamaica, their speed limit's like 70 to 80.
35 miles an hour.
Yeah, in Texas, that's like the same way. Texas goes fast.
I don't know, that's a good question, that's a good question.
It should be
Have you seen
65,
that
shouldn't
Venezuela
it?
driver driving through Iowa? They go like,
New York
I don't know, I didn't look at the
Covering
number.
our eyes, she thought we were gonna die. That's
Who?
Alright. Okay, this is the problem I had up here earlier, correct?
Yep.
Yes.
Okay,
So-
let's discuss.
You did it
Can we
wrong.
back her?
Okay, so the idea is that yes, if we're to evaluate this thing as we approach 0, or, oh, sorry, as we
X minus
approach
two, X plus
2, as we approach 2, here's the problem. If you were to plug in 2, because that's what everyone always
Oh,
wants to
you're
do,
right, Sydney. X plus 2, you are right.
if you were to plug in 2,
It all
You
came.
get
you
0.
get 0 over 0, and that doesn't work,
Why not?
because you can't divide by 0, it's that black hole in math.
So that's why I put no
It's,
solution.
it's called indeterminate.
-2.
So I'm
so-
technically right, there's no solution?
Okay, no. This thing,
No.
this thing
Well,
has a limit. It has a limit. Because if you actually look at the graph and you look at
Negative
all the
2.
evidence, there is an answer where this thing is approaching if you were to graph it. It's not indeterminate. When you look at the graph, there's an actual answer. The problem is, at 2, you can't see it. You have to factor to be able to eliminate those extraneous things so that you can actually see what's about to happen. That's what a limit's great for. The answer says it's supposed to be no solution.
You're right, it's negative.
But as you approach the right and left at 2, things start to work. So how you do it, the best way, one strategy is to factor. How do you factor the top?
X plus 2, X minus 2.
Okay, boom,
You
it's
just
the
plug
difference
in
of
like
squares.
one-
And then it's over X minus 2, so you cross those
It's
out, you get
an
X plus 2, and your solution's -2.
Okay,
There you go.
4.
Why is it 4?
Told ya.
because if you plug in 2,
I told
Wait,
you
what?
too.
you have to
Okay,
plug in the
so I cancel the X minus 2.
Okay, so I got most of it
Okay.
right though.
I got it all
Hey, so you plug in X minus, you get rid of the X minus 2. By the way, this is called a removable discontinuity. And when I get rid of it, what I'm left with is this.
Line.
And what you're supposed to do is plug in the 2.
Put the line in the.
2 plus 2 is 4. Now, earlier, if you're looking at the graph, you're like, there was no solution. The original problem said there was no solution. Why is this one have 4? Because when you actually look at a graph of this thing, what's happening here is this is what's taking place. It's coming down at 2. So at 2 here, 1, 2, 3, 4. This graph has a hole in it
Why does it
on
have
that
a-
graph. The reason why it has a hole.
Removable discontinuity.
Yeah, the idea is that there's a hole because if you look at the bottom of the graph, you're not supposed to use 2 as one of the x numbers of the domain. But it removed itself. So that means there's just a hole in the graph. The graph almost looks continuous. And since there's a hole, this thing still has a it still has a limit.
A predicament?
It has a limit, and that's where the graph is approaching the right and left side. Okay. Last thing I want to do here. We have some paper that I would like to hand out, and I want to see if you're paying attention today how well you can do that.
Is it the same problem cited before?
I bet
Same
it isn't.
style of problem.
No, I bet it's.
Fire demonstrator.
I don't have a piece of
Hey,
paper.
what does Lynn mean?
Okay, no talking to your neighbor. There's two problems, there's the front and the back, put your name on it. We're gonna compare it.
What? So I can't use
You
that?
put the lemon, the coconut,
Oh no.
and shake it all up.
Have you ever gone 162 miles an hour?
Definitely not.
Have you ever gone 100 miles an hour?
No.
What zero are
That
we
is
speaking
just
of?
a
I
lot.
find that hard to answer.
What zero are we speaking of? Like X?
What?
Is this the X?
That's X, coaches, he
Oh,
wrote
my
first
friend.
time.
I already.
Correct.
have lost.
Wait, this is only 2 problems.
Okay.
Wait, why do I have 2?
Oh, sorry. Okay. There's the front and back. Don't check your neighbor. I want to see if you guys can figure out what to do here.
Haha. Interesting.
Okay, when you're done, I'll take it.
Does that look right? You're not gonna look at it right? It doesn't look right? Okay. Just roll it off.
That's correct.
Like